Hey folks, Dr. White here. We're going to be doing some problems involving solutions. So when we do these problems, you always want to keep in mind what we're talking about when we say the word solution. A solution is anytime you dissolve a solute or any sort of solid into a solvent, okay? Usually this is the liquid phase. Think about making a cup of hot chocolate, right? You need to dissolve the chocolate into the water or the milk. You're making a solution where the hot chocolate or the chocolate powder is the solute and the hot water or hot milk is the solvent, okay? Now, let's say that we're a chemist and we try to dissolve sodium chloride into water to produce a 1.5 M solution. Well, what does M mean? M, big M, equals moles over liters or decimeters cubed if you're an IB student. So basically it's how many moles of solute are in how many liters or decimeters cubed of solvent. So it's a way of it's a this per that number that describes how much stuff, how much solid you have dissolved in your liquid. Okay, and it's called the concentration. So if we have a 1.5 M solution, that means our solution is 1.5 moles of NaCl in 1 decimeter cubed of liquid. Remember, 1 decimeter cubed is 1 liter. So how might a chemist use this ratio to help them? Well, if you know the ratio of solute to solvent, then you can do things like you can take a volume of liquid out of solution and you'll know exactly how many moles of solid you'll have. And I'll show you an example of this later on. Okay. Now, if we have an amount of grams of our solute and we have our volume, we're almost there. We can almost figure out what the concentration of the solution is going to be. The issue is that we need the molar concentration. Concentration is most often talked about in terms of moles per decimeter cubed. Let's figure out what the concentration of this is going to be in moles per decimeter cubed. Well, we need moles. We have grams. So we've got to convert grams to moles. Well, we can do that, all right? The question is, in 45.3 grams of potassium nitrate, how many moles is that? Well, if we use our molar mass from our periodic table, we can figure this out. In 1 mole of KNO3, K is 39 grams per mole. Nitrogen is 14 grams per mole. And we got 3 times oxygen, which is 48 grams per mole. So if we add these up, we get 101 grams per mole. So 1 mole of KNO3 is 101 grams. Now, we can set up a ratio. Put this number over that number, and then x, what we're trying to find, over this number, set it equal to each other, and solve for x. So we've got 0.449 moles of KNO3 in that 45.3 grams. So we've got the moles piece. Now we just need to figure out what our volume is. 225 milliliters. Well, we're trying to get our molar concentration in terms of decimeters cubed. So how does milliliters relate to decimeters cubed? Well, remember, a milliliter, I'm going to be up here on the right here, a milliliter is equal to 1 centimeter cubed, all right? And 1 centimeter cubed is equal to 0.001 decimeters cubed. So if we take 225 milliliters, cross out those milliliters, and let's just say 225, and in the place of this, I'm going to put in 0.001 decimeters cubed, then I'll get to decimeters cubed. And that's going to be 0.225 decimeters cubed. So now you take your moles, 0.449 moles of KNO3, divide by 0.225 decimeters cubed, and your concentration is going to be equal to 2.00 molar KNO3. Okay, similar type of problem. We've got a mass and a volume. Let's figure out what the molarity is. Molarity is just the concentration in moles per decimeter cubed. Well, let's find moles first. To do that, we're going to need the molar mass of copper sulfate. I'm going to go ahead and do that right here. Copper sulfate is 159.5 grams per mole. So if it's 159.5 grams is in 1 mole, if I have 275 grams, how many moles is that going to be? Well, just set up the ratio. Solve for x. This will be 1.72 moles of copper sulfate. Now, 4.25 liters. Now remember that a liter is equal to 1 decimeter cubed. So if we want to figure out what the molarity is in moles per decimeter cubed, we just take our moles, 1.72 moles, divide it by our liters or decimeters cubed, 4.25 decimeters cubed, and solve. If you work this out, it's 0.405 moles per decimeter cubed. Okay, number 4, talking about a tincture of iodine, which is just an alcoholic solution of iodine. You dissolve 5.515 grams of iodine crystals to make 225 milliliters. What's the molarity, right? Remember, molarity, moles per decimeter cubed. Let's figure this out. Well, if you've got 5.15 grams of iodine, remember that's I2, how many moles is that going to be? Well, if I know how much is in 1 mole, I can set up a ratio. 1 mole is 254 grams. Okay, set up the ratio, grams over grams, moles over moles, solve for x, 0.0203 moles of I2. Okay, now we're trying to find what's the concentration if we do 225 milliliters. 225 milliliters is equal to 225 centimeters cubed. And remember, a centimeter cubed is 1,000th of a decimeter cubed. So all we have to do is move that decimal place over to the left 3 places. 0.225 decimeters cubed. Take your moles, divide by the volume in decimeters cubed. Our molarity is going to be 0.0902 moles per decimeter cubed. Okay, so now they're going to ask a little bit different question. Okay, they want to know about the volume of a known concentration. So this is something new. Okay, so what is our concentration? That's going to be 0.025 moles of sodium chloride per decimeter cubed. Okay, Now, if we take 5.2 grams of sodium chloride and we want to make a 0.25 molar solution, how much solution is that going to make? Well, first step, let's go from grams to moles. Okay? When in doubt, probably a good idea to go from grams to moles. So I'm going to do this a little bit in a different way. I'm going to take 5.2 grams of NaCl and I'm going to divide by the molar mass. This is the same thing as setting up our ratio problem. I'm just doing it in a little different way. I'm dividing our mass by the molar mass, and that's going to give me how many moles I have. I'm going to get 0.0889 moles of NaCl. Whenever you divide a mass by its molar mass, you're going to get moles. Okay, so that's how many moles I have. Well, if I know how many moles I have, and I really want to know what my volume is, so I'm going to put this on the right. I'm trying to figure out what this is on the right. If I use my concentration, I can figure out what volume I need. And it works like this. I've got moles here. Go ahead and put the moles on the bottom so you can cancel that out in terms of units. On top, I'm going to put decimeters cubed. This is just my concentration. It's the I'm taking the reciprocal of my concentration here. And I know that in 1 decimeter cubed of my solution, I've got 0.25 moles. Moles is going to cancel, and I'll be left with decimeters cubed. So I'm using my concentration to figure out my volume. And that's what chemists do all the time. This is why concentration is so useful. If you know the moles that you want, and you know the concentration, you can figure out the volume that you need. And it turns out that I'm going to need 0.356 decimeters cubed of my solution to give me 5.2 grams. Okay, number 6. People tend to get confused on number 6 because they forget that when you dissolve ionic substances in water, they break up into individual ions. So for example, aluminum chloride, it doesn't just break up and stick in chunks of aluminum chloride. It actually breaks up into its individual ions, and you got to know how that's going to work. So aluminum turns into Al3+, right? And then we got 3 chlorides. So this concentration refers to the whole group of ions before they break up. Hence, you've got to multiply the ratio of the ions by the concentration if you want the concentration of each individual ion. For example, I've got 1 aluminum per aluminum chloride. That means that I'm going to have a concentration of 0.25 molar aluminum because the ratio is 1 to 1. Now, I've got 3, 1, 2, 3 chlorines. So I need to multiply my original concentration by 3 if I'm going to figure out how many chlorines I have. My chlorines, the concentration of chlorine is 0.75. All right, let's kind of move on and we'll see if we can make this a little bit clearer for you. So now I've got this ionic compound. Let's keep in mind how this breaks up. When this breaks up, you're going to get 2 sodium plus, and this is a polyatomic ion, CrO4. This is chromate. So this is going to stay as one chunk. The polyatomic ions stick together. Now let's figure it out. Now I'm going to do this in a little bit different way. Maybe this will be clearer. If you take the concentration of the whole and you multiply, let's do this for sodium. I have 2 sodiums per 1 big chunk of sodium chromate. If you do that, cancel out the chromates, you'll find that if you multiply the original concentration by 2, you'll get the concentration of sodium. You can do the same thing for the chromate, multiply by the ratio. Now the ratio for chromate is just 1 chromate per 1 sodium chromate. So it's just 1 to 1. That means the ratio or the concentration stays the same. Okay? Calcium hydroxide. Remember, we get 1 calcium, 2 hydroxides. Okay? We can work this out in 0.002 molar calcium hydroxide. If we multiply that by our ratio of hydroxides, which is 2 per 1 calcium hydroxide, we find that our new concentration of hydroxide is going to be twice that of the original. And then for calcium, there's just 1 calcium per calcium hydroxide, so calcium is just going to be the original concentration because it's 1 to 1. Last but not least, sodium phosphate. We're getting 3 sodiums out of here and 1 phosphate. Hence, multiply the original concentration by 3 for sodium, and for phosphate, it's just going to be the original concentration. Now, the question is, how many grams of silver are needed to prepare 250 milliliters of 0.100 molar silver nitrate solution? Well, if you know the concentration, you actually know quite a bit. So, here's what I'm going to do. I'm going to start out, I'm going to turn this into decimeters cubed. 0.250 decimeters cubed here. And I'm going to put it right here on the right. Now, this is silver nitrate. I'm trying to find, go over here to the right side, draw an equal sign, and figure out what we're trying to find. We're trying to find grams of silver nitrate. So how do we get from the left side to the right side? Well, you've got a conversion factor. This conversion factor is your concentration. You know that the concentration in moles per decimeter cubed is 0.100 of silver nitrate. If you multiply these two values, decimeter cubed is going to cancel and you're going to be left with moles. Well, moles is closer to grams than the volume is. So you're almost there. You've just got to multiply by the last piece, which is getting from moles to grams. Well, you know how to do that too. If you take the molar mass in grams per mole, in 1 mole, what's the molar mass of silver nitrate? Silver nitrate is 169.9 grams per mole. Moles cancel, and now you have all your numbers. You know how to multiply them together now. It's 0.25 times 0.1 times 169.9. You are going to need 4.24 grams of silver nitrate. So we just used the concentration and the molar mass to get from volume to grams. Okay? Now we're going to do the opposite. We're going to go from grams to volume. Now start by putting grams over here on the left. This is what you know. Now, always go from grams to moles. You can do that by dividing by the molar mass. What is the compound? It's silver nitrate. And silver nitrate is 169.9 grams per mole. When you do that, you divide grams and you cancel out your grams, and that's what we want. Now we're in moles. Now, we're trying to find the volume of the solution. That's going to be in decimeters cubed. Well, I've got moles now. How do I find the volume? Well, I've still got my concentration I can use. But I can't just put my concentration into my equation. I actually have to figure out a way to get it so that it's going to yield a volume. If I take the concentration and flip it so that volume is going to be on top, decimeters cubed, and moles is going to be on bottom, it's 0.25 moles per 1 decimeter cubed. My moles are going to cancel, and I'm going to be left with what I want, which is decimeters cubed. So to solve this, you take 10 grams, divide by 169.9 grams, and then divide again by 0.25, and we find that we need 0.235 decimeters cubed of solution. Okay, last one, number 9. Concentrated hydrochloric acid made by pumping hydrochloride into distilled water. If concentrated HCl contains 439 grams of HCl per liter, what is the molarity? Okay, well, let's do this. Let's just write this down. 439 grams HCl per 1 liter or 1 decimeter cubed. We're trying to find the molarity. Well, what are the units of molarity? Moles per decimeter cubed. So we're almost here, only we've got grams instead of moles. Let's change the grams over to moles. How do we do that? We use our molar mass from the periodic table. So take grams, because that's what we want to get rid of and cancel out, put it on the bottom. Take the moles, put it on top. And the question is, in 1 mole of HCl, how many grams of HCl there is? Well, if you add it up, it's 36.5 grams per mole. Grams cancels. In the end, I'm left with moles per decimeter cubed. That's what I want. And I've got 12.0 molar HCl.